Welcome to The Explainer. Today, we are going to break down a term that you hear absolutely everywhere, machine learning. And look, it's not just for data scientists or, futuristic robots. It's actually the invisible engine behind your movie recommendations, your spam filter, even the way your phone unlocks with just a glance. So what is it really? Let's dive in. All right, so let's get one thing straight right off the bat. This is not some far-off sci-fi concept. Machine learning is already here, running quietly behind the scenes of so many things you use every single day. I mean, think about it for a second. How does your phone or your email or your favorite streaming service seem to know exactly what you want, sometimes before you do? Well, I can tell you, it's not magic. It's machine learning. That's right. When Netflix just knows the next show you're going to binge, or when Alexa somehow understands your command over all the noise, or when your phone recognizes your face instantly and your bank flags a weird transaction, these aren't just clever features. They are all powered by systems that have learned to recognize patterns, kind of like we do. Okay, so what is the official definition? Well, machine learning is a part of AI where we get computers to learn from data without being explicitly programmed. Now, that last part is the absolute key. Instead of a developer sitting down and writing a million if-then rules, we just feed the machine a ton of examples and let it figure out the patterns for itself. So, how do machines actually learn? It's not just one thing. In fact, there are three main ways they go about it, and each one has a really unique approach to making sense of data. First up, we've got the most common and probably the most straightforward type. It's called supervised learning. The best way to think about this is like learning with a teacher. Imagine you're trying to teach a computer to identify pictures of cats. With supervised learning, you'd show it thousands of pictures, and each one would already be labeled cat or not a cat. The machine literally has the answer key, so it learns by connecting the dots between the label and the image. Your email inbox is a perfect example of this in action. The system learns what spam looks like because it's been trained on millions of emails that people, like you and me, have already marked as spam. It sees the patterns in those emails and then applies that knowledge to all the new stuff coming in. Okay, so now, what happens when we take away that answer key? What happens when there's no teacher? Well, that's where unsupervised learning comes in. Think of this one like a detective showing up to a crime scene with zero instructions. The machine is just given this huge, messy pile of data and is basically told, go find the interesting patterns. It has to look for clues and connections all on its own to group similar things together. You see this used in business all the time. An online store can just dump all its customer purchase data into an unsupervised model. And that model might automatically discover groups like, say, frequent bargain hunters, or high-end electronics buyers, or weekend shoppers, all without ever being told what groups to look for in the first place. Pretty cool, right? And finally, we have reinforcement learning. This one works on a completely different principle. It's all about learning from trial and error, based on feedback. Honestly, this is almost exactly like training a pet. When the algorithm does something good, it gets a reward, like a digital treat. When it makes a mistake, it gets a penalty. So over millions of tries, it just learns to do more of the stuff that gets it rewards. This is exactly how AIs learn to master incredibly complex games like chess or Go. They play against themselves millions and millions of times. A winning move is a reward, a losing move is a penalty. And through that relentless process of trial, error, and reward, they eventually discover strategies that are way beyond what any human could ever come up with. So we have these really powerful ways for machines to learn, but how do you actually go from having a problem you want to solve to a working model that can make predictions? Well, it's a pretty structured process. It's a workflow that always starts with defining a really clear goal. From there, you collect your data, then you have to clean it all up, select the right kind of model for the job, train it, and then finally, you test how well it actually works. But here's the crazy part. One of these steps takes up almost all of the time. So, take a look at this number, 80%. Now, think back to that process we just saw. What single part of the whole thing do you think takes up 80% of all the effort? Yep, the most time-consuming and honestly, the most critical part is not the cool, glamorous model building. It's the painstaking, detailed work of cleaning and preparing the data. Because real-world data is messy, it's incomplete, and a model is only ever as good as the data you feed it. Now, machine learning is an incredibly powerful tool, but it is not a magic wand. It has some amazing strengths, for sure, but it also has some very real pitfalls and limitations that we absolutely need to talk about. One of the biggest technical hurdles is getting the learning just right. If a model learns its training data too well, we call that overfitting. It's like a student who just memorizes the answers for a test but can't actually think for themselves. But if the model is too simple, it's underfitting. It just fails to see the patterns at all. The real goal is always to find that perfect balance right in the middle. When it works well, the advantages are huge. I mean, machine learning can automate tedious, complex tasks. It can analyze data at a scale no human team could ever dream of, and it can uncover these hidden insights that lead to way smarter decisions. But here's the other side of that coin. These models are hungry. They need massive amounts of data and a ton of computing power. And because they learn from data, any bias in that data gets learned right into the model, leading to biased results. It is the classic principle of garbage in, garbage out. So, after seeing what it is, how it works, and its potential traps, let's put it all into perspective. Where does machine learning really stand today? If you take just one thing away from all this, let it be this. Machine learning is not science fiction that's waiting to happen. It's already here. It's reshaping entire industries, and it is woven into the very fabric of our digital lives. The real question isn't if it will impact you, but understanding how it already is every single day.